Ever wondered how a fighter jet can simply vanish from radar, not disappear in a science fiction sense, but become so difficult to detect that even the most advanced tracking systems struggle to acknowledge its presence? It is not only about what radar cannot see, it is about what is happening directly on the aircraft's surface, a microscopic level where airflow bends, energy scatters, heat dissipates, and physics itself appears to be quietly manipulated. Today, we are peeling back the layers of stealth aircraft coatings, not just to talk about radar absorption, but to expose the unseen aerodynamic forces at play. Forces that go far beyond paint, far beyond angles, and far beyond what most people believe stealth truly is. This is the hidden science of low observability. Beyond radar absorption, the stealth myth debunked for decades. Stealth has been explained in simple terms. Radar waves hit an aircraft, special materials absorb those waves. The aircraft becomes invisible. It is a neat explanation, and it is largely incomplete. Radar absorption is only one piece of a far more complex puzzle. True stealth is not a single technology. It is an ecosystem of physics, material science, aerodynamics, thermal management, and electromagnetic control. Low observability does not mean invisible. It means difficult to track, difficult to lock, difficult to predict, and extremely difficult to engage. Stealth aircraft are designed to confuse detection systems at every stage, from long-range surveillance radar to fire control, radar to infrared tracking systems, and even visual acquisition, and coatings play a role in every one of these layers, but not in the way most people imagine. The microscopic dance, surface engineering for airflow control. At cruising speed, a stealth aircraft is surrounded by a violent environment. Air molecules slam into its surface at hundreds of meters per second. Shock waves form boundary layers, develop heat, builds rapidly. Traditional aircraft coatings focus mainly on protection against corrosion, against temperature, against where stealth coatings are different. They are engineered surfaces, designed at the microscopic level. These coatings are not smooth. They are carefully textured at scales smaller than the width of a human hair. This texture manipulates the boundary layer, the thin region of air where airflow transitions from smooth laminar flow to turbulent chaos. By controlling this transition, stealth coatings reduce radar reflective turbulence, minimize heat spikes, and alter how electromagnetic waves scatter across the surface. Is where aerodynamics and stealth merge. Behavior directly affects radar signature. Turbulent airflow can amplify radar returns, while a controlled boundary layer reduces unpredictable reflections. Stealth coatings quietly guide airflow, smoothing it, stabilizing it, and keeping the aircraft's signature consistent. And low radar interaction scattering. Instead of absorption, radar waves do not simply bounce or vanish, they interact with surfaces in complex ways. Stealth coatings are designed to scatter radar energy, not merely absorb it. At the microscopic level, these materials redirect electromagnetic waves into multiple low-energy paths instead of a strong return signal. Radar systems receive fragmented, noise-weak, unreliable, and inconsistent. This scattering effect is enhanced by surface geometry, material layering, and embedded conductive particles within the coating itself. Some layers convert radar energy into heat, others redirect it laterally, and some delay the signal long enough to confuse tracking algorithms. Radar systems rely on predictabilities. Stealth coatings thrive on chaos. Thermal signature control, beating infrared detection is not the only threat. Modern battlefields rely heavily on infrared tracking. Heat is often easier to detect than radio wave. Stealth coatings help manage this threat, as well. Advanced thermal regulating layers distribute heat evenly across the aircraft. Surface instead of hotspots forming around engines or leading edges. Heat is diffused, spread, redirected, and blended with ambient air temperatures. Some coatings even alter emissivity, the rate at which heat radiates outward. By controlling emissivity, stealth aircraft appear cooler than they truly are. 2 infrared sensors. They blend into the background, not invisible, but indistinct, just another piece of atmospheric noise. Environmental adaptability. Coatings that change behavior, one of the least discussed aspects of stealth coatings is adaptability. Modern stealth materials are not static. They respond to altitude, temperature, humidity, and speed. At high altitude, where air is thinner, the coating behaves differently than it does during low-level penetration. At supersonic speed, thermal and aerodynamic stresses alter surface behavior. Some stealth coatings are designed to self-heal at a microscopic level, repairing small cracks that would otherwise increase radar signature. Others change electrical properties in response to environmental conditions. This is not paint, it is an active system, quietly responding to its surroundings. Why stealth is maintenance heavy? There is a cost to this invisible magic. Stealth coatings are fragile, complex, and surface damage can dramatically increase detectability. This is why stealth aircraft require controlled hangars, special maintenance procedures, and constant inspection. Every scratch, every chip, every imperfection matters, because stealth is not one technology, it is the sum of thousands of invisible decisions, all working together. The future of stealth coatings. The next generation of stealth is already taking shape. Metamaterials, adaptive skins, and smart coatings capable of real-time, electromagnetic control. Future aircraft may actively reshape their radar signature. Based on mission profile, they may appear larger, smaller, or completely misleading. The battlefield is evolving, and stealth coatings are no longer passive defenses. They are becoming strategic weapons. The true meaning of unseen forces. Stealth aircraft do not disappear, they deceive through microscopic engineering, aerodynamic mastery, and material science. The unseen forces at play are not magic, they are physics pushed to its absolute limits. And the surface of a stealth aircraft is not just a skin, it is a battlefield where air, energy, and information collide silently. If you want, I can now.